What's good, everybody? In today's video, we're doing the part 2 of the back to school review. We're going to look at 5 more topics that you're going to see throughout the school year. If you find this video helpful, smash the like button for us. So topic 1 is solving equations. When we're talking about solving equations, we want to figure out what is the unknown number. Basically, find out what the variable is. So in this problem, we're going to distribute. We'll have 16x minus 8 minus 4x is equal to negative 116. Now, when we're solving equations, guys, just remember the variables and the numbers with no variables need to be on the opposite side. So for us to cancel out negative 8 and add it to the other side, I'm going to add 8. That goes to 0, add 8 on this side, and then now we could rewrite our equation. So we have 16x minus 4x is now equal to negative 108. And now we could simplify this and get 12x is equal to negative 108. And once we divide by 12, just make sure we don't forget our signs, right? We should have a negative answer. X is equal to, and let's grab the calculator real quick, just make sure. Yep, x is going to be equal to negative 9. And if you ever want to double check your answer, guys, just take it and plug it back in and simplify the equation. Now in problem number 2, I want to talk about fractions because sometimes students get a little bit confused with fractions. But in this problem, we know what is half of 10 and half of 2. But let's say it was a more challenging fraction. What I tell students is make the other numbers a fraction too. So when we distribute, right, multiply top with top, bottom with bottom, we will get 10x over 2 minus 2 over 2. So when we simplify these, this would be 5x minus 1, and we could bring down the rest of the equation. So if for some reason you're not good with fractions, guys, and we're distributing, just make sure the terms inside the parentheses, put them over 1 and multiply numerator with numerator, denominator with denominator, and then check if you could simplify. Now that we can, guys, we're going to add our x's. We're going to get 8x minus 1 is equal to negative 25, right? To cancel out a negative 1, we're going to do the opposite. So we're going to add 1. So we have 8x is equal to negative 25 plus 1. That's going to give us negative 24. And when we now divide, which is our last step, we're going to get x is equal to negative 3 as a final answer. Now, we're going to do one more equation problem before we switch to inequalities. And this problem, I really want to talk about it because they're going to have variables on both sides. And there's one major mistake that I see students make when we have variables on both sides. So let's get this problem down first. So if you watch part 1, I told you guys that they're going to try to confuse us when it comes to using the distributive property. So when we look in the first part of this problem right here, we're not distributing 5x to the parenthesis, to what's inside the parentheses, We're going to distribute this negative sign. So what that means is that the signs of whatever's inside the parentheses will change. If you're a student who struggles with this, put a negative 1 here, okay? So what happens is we have 5x minus x plus 18. And if you notice, the signs just change from what it was inside the parentheses. Now we go on the other side, and the second trick they try to get us with is 6 minus 2. No, we're still following order of operations, meaning to solve we have to multiply first. So after I distribute negative 2, we're going to get 6 minus 2x minus 30. Now this is the biggest mistake I see when we have variables on both sides, and we've all made it before. So students, when they combine on this side, instead of doing 5 minus x to get 4x, right? What they do is think that they have to cancel it out. So they'll say, hey, plus x plus x. But guys, that is wrong. We only cancel out values whether they're constants or variables when they're on the opposite side. If they're on the same side, just add and subtract straight up. 5 minus 4x gives us 4x, bring down 18. Now when we go on the other side, it's the same thing. we're not going to add 30 to 6. We're just going to do 6 minus 30. So we're going to have negative 2x minus, and I want to say that is 22. So now that we have that down, let's make sure that's 22, right? Oh, no, 24. So yeah, that's why you got to double check. All right. So we have negative 24. So now at this step, I'm going to add 2x because I'm moving it from one side to the other. And we'll have 6x plus 18 is equal to negative 24. And now we're going to finish this problem off by subtracting 18 from both sides. Once we do, we'll have 6x is equal to, let's see, 8, 4, that's 2 plus 1, negative 42. And once we divide now, we'll say that x is equal to negative 7. So when we're talking about equations, guys, just remember we're working backwards to solve the equation. And when we have variables on both sides of the equation, you only have to cancel it out and do inverse operations if you move in the variable or the constant from one side of the equation onto the other side of the equal sign. Now we're going to go overhead and talk about solving inequalities. So this part of the video, we're talking about solving inequalities. And before we get into the meat of it, just remember that inequalities are the same exact steps to solve as equations. There's just a few different things. So number one, let's pick this corner. Greater than or less than sign. When we graph, we're going to have a open circle, okay? And then if we have less than or equal to or greater than or equal to, we're going to have a closed circle when we are graphing on a number line. Now, there's something else called interval notation. I'm going to show you guys in that video too, but it also goes off of the inequality signs. So if we have a greater than or less than sign, we're going to use parentheses for interval notation. But if it's a closed, or should I say a closed circle or equal to, we are going to use brackets. And trust me, guys, I'm going to explain all of this for you as we go through it. So problem number one, to solve, right? We're going to work backwards. Subtract 4 with those inverse operations. X is greater than 5 for this to be a true statement. Okay? So when we go ahead now to graph, don't have my ruler, guys. I'm sorry. When we go ahead to graph, right? Let's do 5, 6. This is 4. This is going to be an open circle, and it's telling us that x is greater than 5. So we're going to shade towards the direction where x is greater than 5, which would be to the right side. Okay, so this is how we would solve. Now, if we're talking about interval notation is the same thing as the graph. It's just saying, hey, these are the answers included. But instead of listing all the numbers, we use a symbol called infinity for the positive numbers. And then on the negative side, when we go to the negative numbers, it's going to be negative infinity. So if we're asking for all the numbers included, because we have an open circle, we're going to use the parentheses and we're saying that, hey, this graph starts at 5, right? And we put a comma and we're saying it's going to all the numbers that are greater than 5, but we can't list it. So we use this symbol. And anytime we use this infinity symbol, it'll always have a parentheses around it, never a bracket. So this would be how we graph, solve, in the interval notation. Now, problem number two, this is the biggest key thing with solving inequalities, especially when we have a negative. So after I add 6 on both sides, we're going to get negative 2x is greater than or equal to positive 10. But when we divide or multiply by a negative, right, that x value is negative, we have to flip our signs. So now this turns into x. Instead of greater than or equal to, we're going to have less than or equal to negative 5. So let's say now that we're going to graph this problem. I'm going to erase this. For graphing this problem, right, first we have to remember that the negative side of the number lines it's number different, right? So let's put 5 right here in the middle. So we have negative 5, negative 4, negative 3, negative 6, and negative 7. So we know it's a closed circle because it's already equal to. And it's saying that x is less than or equal to 5. So all the numbers that are less than 5 are the numbers further away from 0, which will be -6, 7, 8, 9, 10, and so on. Now, if we want to represent this using interval notation, just remember that we read graphs from left to right. So we're basically coming from all those negative numbers, but we can't label all of them, right? So we're going to use our infinity symbol. So we're saying that this is coming from negative infinity, right? All those negative numbers on a number line is coming all the way up to -5, and it's going to stop here. And because it's a closed circle, we are going to have a bracket. And this would be the interval notation and graph for this problem. So the next type of problems we're going to look into now are going to be compound inequalities. And just remember with compound inequalities, guys, it's the same exact steps, but we're probably solving two inequalities at one time. So the first one that we're going to look at is the OR inequalities, right? So we have x plus 1 is greater than or equal to 3, or x plus 6 is less than 4. So when we're talking about inequalities or compound inequalities that are OR, right, the graph always goes in opposite directions. Okay? If your graph is running towards each other, you did something wrong. So let's go ahead and solve now. We're going to switch to black. So when we solve, right, -1 on this one, x is greater than or equal to 2, right? That's the first answer. Or, and then when we solve over here, we subtract 6 on both sides, x is less than -2. So now we have our answers, and both of these are going to be on the same exact number line, okay? So let's draw this out some. Sorry, I don't have my ruler with me today, guys. So let's say we have 0 here, right? We got 1, 2, 3. And we got -1, -2, -3. So it says x is greater than or equal to 2. This is going to be a closed circle going to the numbers greater than +2. Then when we go on the other side, it says x is less than 2. So this is an open circle, and all the numbers that are less than -2 are further away from 0, so it's going to the left. And if you notice, right, my graph is going in opposite directions. So 9 times out of 10, this is right. Now, interval notation, guys, it's going to be a little bit more complicated. So if we want to express this one, right, we know it's an open circle, so we're going to have a parentheses around -2. So we know that this graph is coming from negative infinity, right? And it's coming all the way up to -2. And -2 is not included. So we have a parentheses. And then we're going to put or. And sometimes you'll see this symbol like U in union with. It's the same thing as or. And then the graph takes a break from -2 to +2. So it picks back up at 2, right? And it's going to all those numbers that are greater than 2, which we use with the infinity symbol. So this is how we would solve this type of problem. Now, the last inequality problem that we're going to look at is going to be those that are and inequalities. And I've linked a video down below if you need more practice on inequalities, especially the compound ones, okay? So let's erase this and go on to that last one. All right, so this last inequality problem, these are what we call and inequalities. So it's two inequalities in one, and these are going to run towards each other, right? So this graph should look something like this. Or it could be an open circle with a closed circle or two open circles. But the graphs are going to run towards each other. So when it comes to solving, there's two ways we could do this. We could split the inequalities, meaning I could solve for this inequality first and then come back and solve for this second one. But that's a lot of work. What I tell students is, hey, you want to get x in the middle and keep it in the middle, right? It's going to be in the middle. You want to keep it in the middle. So the first thing we need to do is to move our 5, right? So we add it to ourselves, and then we're going to add it to 1, And what I see students make a mistake is they only add it to one side of the inequality, whether it's +1 or -14. Please make sure you guys add it to both sides. So we add 5 to -14 too. So once we rewrite this, let's see, this should be, goodness, I think this is -9, right? This is what we should have now after we add 5 to both sides. Now, we know that the x isn't by itself, and to get it by itself, we have to divide. So we divide 3 by itself, divide -9 by 3, and +6 by 3. So what we'll get is -3 and 2. And this is just let us know when we read it that, hey, x is greater than -3 and less than 2. So when we come down here to graph this, draw a number line out. So -4, -3, 2, 1, 0, 1, 2, 3. We know that both of these are going to be open circles because they're either greater than or less than. So we have -3 here, +2 here. And just so that you guys could visualize this, remember that the graph is going to be running towards each other. So this is how this should look. Now, when it comes to the interval notation, what I tell students is it's the same exact numbers on the graph. So we know that this graph runs between -3, comma +2. And because both of them are an open circle greater than or less than, that means we use parentheses because they are not included in the answer. Now, what we're going to do at this step, guys, we're going to move over to solving or rearranging equations and solving for variables. In this part of the video, guys, we're talking about rearranging formulas. So we're talking about working with straight variables. And if you have enjoyed this video so far, smash the like button for us. So in this problem right here, they want us to solve for W. So basically, we want to have the equation where it says W is equal to, get it all the way by itself. So to do that, we're going to subtract 2L. And just remember, guys, that rearranging formulas, equations, really formulas, I'm sorry, they're just trying to check your understanding of concepts. So to solve for W, we would have to subtract 2L so that we could isolate W. But once we subtract 2L, we cannot combine it with P because they're not like terms. Okay. So after this first step, we would have P minus 2L is equal to 2W. And for us to get W by itself, right, we're multiplying 2 and W. So the opposite is dividing. So I would divide by 2. And now if I rewrote this, we would say W is equal to P minus 2L over 2. And that would be our final answer. So when we're talking about rearranging formulas, they're checking if you guys understand the concept behind solving equations. Now, in the second problem, they want us to solve for V. And please pay attention to this because you're going to see this a lot in radical equations, and they're going to always do it when there's an exponent because they want to see if you remember how to get rid of exponents. So the first thing we're going to do for us to get V by itself is let's multiply by 2. Multiply by 2, that's gone. Multiply by 2. We have 2E is equal to M times V squared. Now, similar to 2W, M and V are being multiplied. So I'm going to divide by M. So 2E is over M is equal to V squared. Now, for us to get rid of an exponent of 2, we have to take its square root. So I take the square root here, take the square root here, and then now what happens on the right side is V is by itself. The exponent is canceled out, and now we know that the square root of 2 times E divided by M is going to equal to V. So when we're talking about rearranging formulas, guys, they're checking if you understand how to solve equations and the concepts behind it, okay? So just remember that, and I'm going to link a video on this topic down below for you as well. Now, the next topic, we're going to move on to exponents. This part of the video, guys, we're talking about exponents. I'm going to go over all the rules and everything you need to know. So the first one is the product rule. So the product rule, and I don't even like going by rules, but what we're saying is when we have the same base, right? Base of x, or whether it's 2, 3, 4, whatever, and we're multiplying, instead of writing it out, what we can do is simplify it by adding the exponents. So x to the fifth times x to the third, once I add the exponents, we'll say that, hey, this is x to the eighth power, okay? And that will be our answer. We just add 5 plus 3. Now, in problem number 2, they try to put parentheses around it to kind of fool you, but it's the same thing. Our base now is just 3. So I have 3 to the fifth power times, and anytime you don't see an exponent over a number, always assume it's 1. So 3 to the fifth times 3 to the first power. When we add those exponents up, 5 plus 1, we'll get 3 to the sixth. All right? And then in the very last problem, even if they put in 3 terms, right, you just add one more time. So basically, we have x squared plus x to the fifth plus x to the third. And once we do this, we're going to get x to the 10th power. So this would be the product rule, okay? And the next rule that we're going to look at is going to be the zero exponent rule. And all that is saying is that anything to the zero power is going to be equal to 1. So x to the 0 is equal to 1, 1 to the 0 power is equal to 1, a to the 0 power is equal to 1. So this is what the zero exponent property is. And an example of when you would see this, um, let's go right here real quick. I'll jump into it. Let's say we had something like this. We have x to the fourth squared all over x to the eighth. And to solve this problem, we would multiply these two exponents. Would have x to the eighth divided by x to the, x to the eighth. All right, and I'll talk about this rule too. But when we have fractions with exponents, what we do is we subtract them. So we subtract bottom from top. So if I were to do this, we would have x to the eighth minus x to the eighth, which will just give us x to the 0 power, which is equal to 1. And with that being said, the next rule that we're now going to talk about is the quotient rule. So this is when we have fractions and we're trying to simplify them because those fractions have exponents. So let's go, right? So we have x to the a over x to the b. This is the rule you're going to see, and you're going to do x to the a minus b to get your answer. All right. So in problem number 1, let's write these problems out real quick. We have 2 to the 14th divided by 2 to the ninth. That's number 1. X to the 23 over x to the 15th. And then we have, oh, I think that's it. All right. So when we look at the quotient rule, guys, we have 2 to the 14th power minus 2 to the ninth power. And once we do, we're going to have 2 to the fifth power as a final answer, just subtracting the exponents. Now, when we go down to this problem, it's the same thing. X to the 23 minus x to the 15th. And once we do, we should get x to the eighth power. So when we're talking about fractions with exponents, guys, this is how we're going to simplify if they have exponents. Subtract the bottom number from the top. Now, you're probably saying to me, Mr. Peters, what if that bottom number is larger than the top and I get a negative exponent? That's now, we're going to go into the negative exponent rule. So with the negative exponent rule, guys, it's saying that we're going to take the reciprocal. All right. So let me show you what I mean. So x to the negative 1 is equal to 1 over x. Or I should say x to the negative a is equal to x to 1. My bad, guys. I'm rushing. X to the negative a is equal to 1 over x to the a. So what does that mean? X to the negative fifth power. If I wanted to use the negative exponent rule, we would turn it into a fraction and take its reciprocal. So now we have 1 over x to the positive fifth. Okay, so in a typical problem, what you would see is go to our examples real quick. I'm going to do 2 of them with you guys. So let's say we had this. We had 4x squared all over 8x to the fifth. That's number 1. And then number 2, we're going to have x to the negative 6. Oh, I'm sorry, not the negative 6. Negative 3, y to the 4th squared all over x to the 5th, y. So with the rules of exponents, guys, they're gonna start mixing them together, and you have to be, or actually have to know them. So what we're gonna do here, guys, we're gonna simplify the fraction. So we'll have 1 over 2. And what we notice is once we subtract, we will get x to the negative 3. Now, to make this right or to correct this, we would have to bring x to the negative 3 down to the bottom of the fraction. And our final answer would be 1 over 2x to the positive third power. So this is what the quotient rule would look like when you're actually solving on your homework or on the quiz. Now, this next problem is going to work into our final exponent rule. All right, and I'm going to do that. I'm going to show you that rule after we take care of this problem. So when we have more than one exponent, right? So we have parentheses, we have an exponent on the outside. 2 exponents, we're going to multiply. So I'm going to multiply 2 times 3. I'm going to get x to the negative 6th power, y to the 8th power, and this is all over x to the 5th, y. Now we're not done yet because we have a fraction, and remember, we have to subtract our exponents. So I'm going to get x to the negative 11, y to the 7th power, right? And to finish this problem off now, I'm going to turn it into a fraction, and only my negative exponent, x to the negative 11, is going to come to the bottom. So our final answer will be y to the 7th power divided by x to the positive 11th power. And this is all that we could do with this problem. Now, to sum it all up and bring this back together, we're now going to work with the power rule, okay? And the power rule is basically what you see me do up here in this top half part of the equation, the fraction. Okay, so when we're talking about the power rule, guys, just remember that 9 times out of 10, you're going to see parentheses and you're going to see an exponent inside the parentheses and an exponent outside. And all you have to do is remember to multiply your exponents. So 2 to the 3rd power is going to give me 8, x to the 5th. So times 3 is going to give me x to the 15th. That's my final answer. Now, when I go down to my second example now, we're going to multiply our exponents, and we're going to get x to the 14th power as a final answer. And in the last example, right, 5 times 5 times 5, we took it to the 3rd power. We're going to get 125, x to the 12th power, y to the 6th power. So when we talk about the properties of exponents, guys, this is how you would work with them. Like I said, I'll link the video down below for you. And what we're going to do now in this video is move on to the last topic of the day, and that's going to be simplifying radicals. Last part of the video, guys, we're talking about simplifying radicals. And if you could really understand this topic, it's going to make the second half of the school year 10 times easier. So rule number 1. The number under the radical, right? This symbol's a radical. The number under it is going to be called a radicand, but I like to use the word base. And in this part right here, we should know that is the root slash index. And right under the radical symbol by the variable is the power. So when we look at a regular problem, right, what we have to understand is that even if we don't see it, we have a power of 1 and a root of 2. That's automatic, but we never see it, okay? So for us to simplify radicals, we have to know our square roots and our perfect squares. And we want to use that to divide and break down the larger radicals. So when we're looking at 300, the largest perfect square that goes into it is 100 multiplied by 3. Because this is a perfect square, we could simplify this. This turns into 10 radical 3. And that is our final answer. Now, let's say we look at another example, such as radical 175. If you're very good with multiplication and division, it's a very easy topic. So, off rip for me, 25 is the largest perfect square. So, when I look at 25, I know 25 times, what number is it again? 7. There we go. 25 times 7 gives me 125. And now when I look at these two numbers, no perfect square can go into 7, right? No, so it stays the same. But 25 changes. So now we have 5 radical 7, and this is our final answer for the problem. It's simplified. We can't do anything more with it. Okay? So this is just the basis of breaking down radicals. Now, another way we could break down radicals is when the radicals have variables with them. And it's the same exact process. The only difference now is how do we take care of those exponents. So because the root is 2, whatever your exponent is, guys, we are going to divide it by 2. So 36 is a perfect square, right? So when we simplify this, this turns into 6. And x to the 10th, right? Once we break that down from the radical, it's going to turn into x to the 5th power, right? If you notice, we just divided the exponent by 2. Now, let's say we look at a more challenging problem. And in this challenging problem, we have something like this. 81a to the 4th power b to the 4th power times 2a. This is all under the radical, and they're asking us to simplify. So what I would do is let's split this up, right? So we have 81 a to the 4th, b to the 4th, times radical 2a. We know this 2a, we cannot simplify it anymore, so it's going to stay the same. But when we come over here, guys, just always remember to divide your exponents by 2. So perfect square of 81 is 9. A to the 4th turns into a squared. B to the 4th turns into b squared. And now we just bring down the radical 2a because we can't do anything with it. And this will be our final answer. But what's going to happen is they're going to give us problems where the exponents are not an even number. How do we exactly solve? And I'm glad you guys asked because I'm going to show you. So let's erase this problem right here, erase all this. So let's say they give us a problem like these two. So they gave us x to the 15th, y to the 9th, and then z. They want us to break that down, and they also want us to break down 27x to the 3rd. So let's start off with this one first, 27x to the 3rd. So when we're breaking down 27, I know that the largest perfect square is 9. So 9 times 3 will give me 27. Now, when we're talking about the exponent, this is the trick that I tell all my students. And if you follow it, it can make it easier. We're going to split the exponent. We're going to keep the highest even number with the perfect square. So we know that 2 is the highest even number. So we have x squared here, and that last x we're going to put with the imperfect square, okay? It makes it easier to break down. So right here, right, 9 turns into 3, x squared turns into x, and because we can't simplify 3x no more, we're just going to bring it down, and our final answer is 3x times radical 3x. Now, when we apply the same rule to this problem here, the second problem, let's do the same thing. So we're going to split this, right? I have x and y here, x, y, oops, x, y, and z here. So the largest even number is x to the 14th. The largest even number is y to the 8th. So with the leftover, x to the 15th, y to the 9th, and remember, this is just the first power, so it's going to stay by itself. So now we've split it. Highest even number with the perfect squares, odd numbers are going to be by itself. So when we go to divide now, x to the 14th turns into x to the 7th, y to the 8th turns into y to the 4th. And because we can't divide any of these exponents of 1 by 2, right, they're going to stay the same, and we're going to get x, y, z as a final answer. But before we go, I'm going to just touch on a quick little problem of how to add and multiply radicals. Hopefully you stick around to see that part too. So the reason I teach it like this, guys, is because if you could simplify, the multiplication and adding becomes 10 times easier. So number one, when we want to multiply radicals, right? Let's write this out. Radical 8 times 3 radical 2. Number one, for us to multiply radicals, they have to have the same number in the root. So right here, there's no number in the root. We're going to assume that both of them are 2. It has a root of 2, meaning we can multiply. But if this second radical had a cube root or a fourth root, right, we could not multiply these two together, okay? So that's number one. Now that they do have the same root and we multiply, just remember that you multiply numbers with numbers, radicals with radicals. So 3 is not being multiplied by nothing because there's nothing in front of radical 8. So 3 stays the same. And now we multiply radical with radical. We're going to get 3 radical 16. But anytime you multiply or add, always see if you can simplify. 16 is a perfect square. So now this turns into 3 times 4, and our final answer would be 12 instead of 3 radical 16. So always double check if you could simplify. Okay? Problem number 2. We have 4 radical 6 times radical 6. So same thing as the first problem. There is no number in front of the second radical 6 to multiply with 4, right? So 4 stays the same. Radical 6 times radical 6 is 36. Well, that's a perfect square. So now this is 4 times 6, which will give us 24 as a final answer. Moving on to the last part of this video, guys, we're dealing with how to add radicals. And this is why I leave this for last, because if you could break down radicals, multiplying and addition becomes easy. So for us to add radicals, they have to have the same number under the radical. Once they do, they act like variables, meaning we only add the numbers in front. Because we don't see a number in front of this radical, we're going to assume it's 1. So once we combine these two, we're going to get 2 radical 2 as a final answer. Now, in our second example, we have a coefficient. We have 3 radical 5 plus radical 5. Just imagine that there's a 1 in front of that radical 5. So when we combine both of these, we are going to get 4 radical 5 as a final answer. Now, in our last problem, this is typically how you're going to see addition and subtraction problems dealing with radicals. We have to simplify. So when I look at 18, we could simplify this to 9 times 2. And because 9 is a perfect square, it's going to come out the radical and would have 8 times 3 times radical 2, which will give us 24 radical 2. Now, when we move on to 2 radical 72, largest perfect square we can use is 36. If you use a number that is smaller, you will still get the same answer, but you have to do multiple steps, or more steps, I should say. So we break this down, we're going to have 2 times 36 times 2, right? We know 36 is a perfect square, so this turns into 2 times 6 times radical 2, and we are going to get 12 radical 2 as a answer. Now when we move on to our third term, we notice that we cannot break it down anymore, so I'm just going to bring it down. And once I bring it down, we're going to have 24 radical 2 plus 12 radical 2 plus 16 radical 2. And we're only focusing on adding the numbers in front of the radical. So after I add 24, 12, and 16, if I'm not mistaken, let's double check the notes. The final answer should be 52 radical 2 as a final answer. So this is how you guys would add, subtract, multiply radicals. Really hope that this part 2 review was helpful for you guys. If it was, smash the like button for us, subscribe to the channel, and leave comments for this video or for videos on future topics you guys would like to see. Thank you guys so much for joining me today on Algebra 1 with Mr. Peters.